My name is Kevin Skarupa, and a big thank you to having me out here today, and a big thank you to Nashua ETV to have me on their channel. Very, very fun job what I do. I'm very, very lucky to have the job that I have. It's a very interesting job most days of the year. Even on a very quiet day when it's sunny and warm, my job always tends to, have some very interesting ways that everything kind of happens. Most TV weather people have a story as to why they became a weather person. In mine, most of them have a story of a storm that happened that really got them interested in, whether it was a hurricane or a really bad thunderstorm or lightning that got them really interested in what they do. I am one of those that it's a little bit different. I was starting one time about essentially 5th grade, walking home from school. One of my friends runs over to me, really excited, said he had heard we were going to see a foot of snow that night. So I run home, just as excited, start watching all the television stations. And all the television stations are saying 6 to 12 inches of snow, winter storm warnings are in effect, snow is supposed to start after midnight. So eventually I fall asleep on the living room couch at around midnight, watching the Weather Channel. Next thing I know, at about 6:30 the next morning, my mom is shaking me to wake me up. She says, "Kevin, wake up, you have to go to school." I run over to the window. There's no snow outside, and the sun's out. So all day, while I was being yelled at by my teachers for not doing my homework the night before because I didn't think I was going to have school, I said to myself, there's got to be a reason as to why weather people do that. Why do they say it's going to snow when it doesn't? Or they say it's going to be a beautiful weekend, and it winds up raining each day. So I got sent to the library after school for not doing my homework, to do my homework, and went over to the weather section of the library. And there were probably about 50 different books about weather. Some of them had pictures, some of them told stories. The first book I picked up is a book you guys might know. It was literally just out when I was a kid, called Cloudy with a Chance of Meatballs. Yeah. I'm guessing, yeah, you guys have seen the movie, huh? That's right. Town of chew and swallow, food falls from the sky 3 times a day. That's what the townspeople eat. But you have to imagine when I'm sitting here reading this in 5th grade, at about page 4, when a pancake lands on a school, I said to myself, this probably is not how weather really works. So then I started looking through pictures of other books about weather, and I started seeing pictures of things I had never seen in my own life. I had never seen what a tornado looked like. I had never seen the kind of damage a hurricane or an earthquake could do, or what a volcano looked like when it erupted. And so it really got me interested in weather. So when I was going home from school in 6th grade, 7th grade, 8th grade, instead of going home and watching cartoons or going right outside and playing kickball after school, I would go home and I would watch the Weather Channel. And I'd watch it for hours. I was amazed how they could try to predict and figure out that it was going to snow 4 days away, or how they knew what they were pointing at when they were up there at the wall doing the weather every day. So that's where it all started for me. It all started back in 5th grade on the day that the snow never happened. And ever since then, anything about weather is something that really interests me. We're in really fancy clothes and we're on television. We don't make millions and millions of dollars. We don't drive around in very expensive sports cars. We don't live in huge mansions. We are very normal people like everybody else. It just so happens that my job is on television. I enjoy the weather part about what I do more than anything. The TV part for me, when I was in school learning about weather, just kind of happened. I wasn't expecting to be on TV when I got older. That wasn't really the reason that I did what I did, was to be on television. The reason I do what I do is because I enjoy the weather part about what I do. I'd be just as happy, doing research where they chase tornadoes or fly into hurricanes. I'd be just as happy doing that. But, I actually predict the weather instead and present it to you on television every morning and tell you guys whether it's going to snow that day, whether it's going to be a hot day, what day it's going to be like on the magical weather wheel. Is that what we call it, the weather wheel? Oh, good. Wow. I was lucky. So it's a fun job most of the time. When the weather's great, my job is very easy. We get to be in parades. We get to play in charity basketball games. It's a lot of fun doing what we do. It is those 10 days a year when the weather is a little crazy. Thunderstorms, flooding, lightning, hail, ice storms, wind knocking out power like we had a couple of weeks ago. Those are the kind of days that my job is usually a lot busier. If there was a big storm moving toward the state this morning, I would have to be at work as opposed to coming here, because that's our biggest job. Whether it's 2 a.m. or 2 p.m., when the weather is bad, we should be on television telling you about it. Where it is, where it's headed, what it's doing next. That's our job above anything else, is to protect all of you, so that when a storm is moving in, you know that it's coming, and you have a better way to prepare for it when it's going on. I'll show you guys a couple of pictures that I have here. And through these, you'll see what I mean about when you look at pictures, it kind of gets you really interested in weather. Yeah. What's this? Lightning and rain. Yes, absolutely. Now, we don't see lightning like this very often. Okay, this is a picture taken from a desert. You can see the little cactus in the foreground here, and the cactus probably isn't going to do very well with that lightning around. But what you have to know is we predict a lot of different things. We predict snow. We predict rain. We predict when it's going to be sunny, if it's going to be hot, if it's going to be cold. The one thing that is almost very difficult to predict is exactly when and where lightning is going to happen. Here's how lightning happens. What I want you guys to do is take your hands, rub them together really fast. What happens to your hands when you do that?
It gets hot.
Yeah, your hands get hot. Absolutely. The energy you are putting in to rub your hands together ends in the warmth that is created on your hands. And that is an energy that's out there. That is the same thing that's going on up in the clouds. Do you know how sometimes in the middle of the winter you rub your feet on the carpet and then touch one of your friends? What happens to them? They get a little shock, yeah. And that's exactly what's going on up in the clouds. So you have, imagine, up in these clouds, you have ice, you have water, and you have this dust that has risen through the atmosphere to get to there, and they're all rubbing together, kind of like you're rubbing the feet on the floor. And if you can imagine how crazy it is down here on the ground during a thunderstorm, you can imagine what's going on in these clouds to create the lightning. And since it's all rubbing together, it has this energy that it just has to release. And it does it in one of a couple of ways. Let's see here. All right. So here's the thundercloud, all right? It does it in one of a couple of ways. It will look for something tall, something made of metal. Lightning is attracted to water, so it will look for a swimming pool or a lake, and it will come toward the ground. It happens like that. It happens really fast. It's not like you could actually watch lightning slowly come toward the ground. It happens really quick when it happens. And it's hundreds of degrees. It's really hot stuff and very dangerous because of that. But there's no way to tell what tree it's going to hit, what power pole it's going to get at, what body of water it's going to hit. It just comes down just like that. It can also go toward another cloud, because what happens is the cloud next to it is doing the same thing that that cloud is doing. It's rubbing together and has to release the energy. So sometimes the easiest way to release that energy that builds up is to send it toward another cloud. Now, here's one of the interesting things. In weather, we don't completely understand everything about it. We use really fancy computers now, but there's a lot about weather we don't completely understand yet. One of the things we don't completely understand yet is lightning, because there was a third type of lightning that actually we found a couple of years ago. Lightning that goes up towards space. And as we talked about, lightning is going to release energy somehow, and it's going to look for something metal, something water, something tall, or another cloud. But if it's going up toward the moon, I guess, in the direction of the moon, or no oxygen like there is in space, it's not really going toward anything. What they found out eventually is that the lightning eventually turns sideways, about 4 or 5 miles up in the sky, and then comes toward the ground. Sometimes 5 or 6 miles away. Sometimes the thunderstorm that's over Nashua the lightning strikes in Manchester, 20 miles away. Yeah, it's pretty amazing stuff. That's a long distance it travels. And that's one of the types of lightning that's really dangerous, because chances are, if that happens, it's not raining where the lightning eventually strikes in Manchester, because thunderstorms only work in one town at a time. And chances are the sun may be out. So we've had these situations in the past where people have been struck by lightning on a sunny day. Doesn't mean there isn't a thunderstorm around. It's usually about 20 miles away. But it's one of those situations that you have to be listening, because lightning makes a sound, doesn't it?
Yeah.
What's that sound called?
It's like a growling sound.
Yes, it makes a growling sound. You know what that growling sound's name is? When it goes...
Ooh, thunder.
Thunder. Very good. Now, you can figure out how far lightning is from where you're standing. Let's say you're outside and you see a flash of lightning out in the distance. You can actually count to figure out how far that lightning is away from where you are. After you do that, go inside. You don't want to be outside during a thunderstorm, actually, at all. In a thunderstorm, you see the lightning. Let's say you see a big flash come out of the sky. You can start counting. 1 New Hampshire, 2 New Hampshire, 3 New Hampshire, 4 New Hampshire. When you get to 5 New Hampshire, and then you hear the sound of thunder, that rumbling sound, that means that the thunderstorm is 1 mile away from where you are. So for every 5 New Hampshires that you count, it's a mile away. Now, a mile is about from, let's say, here to the highway. Not very far. 5 seconds seems like a long time to wait for that flash of lightning to make the noise. But it really isn't all that far. And so that's one of the really tricky things about our job, is we can predict a lot of different things. But exactly where lightning is going to strike is impossible. It really is. We know that a really tall antenna on the top of a mountain is going to be hit several times a year, just because it's on a tall place and made of metal. But to predict exactly what tree it's going to hit in town when a thunderstorm is moving in is just tough to do. So the best thing you can do during a thunderstorm is to get inside and wait it out, because most thunderstorms don't last all that long. All right. What's this? Lots of different names for this. A who?
Explosion.
It kind of looks like that, but what's this little cylinder here that you see?
Tire.
It's spinning around really fast. Tornado. Also known as a twister. In the olden days, they used to call it a cyclone. And you know what they call it in Australia? It's funny. They call it a willy willy. I can't make something like that up. I'm not that creative. But I guess that's really... Oh, look, there's a willy willy. Let's go inside. Doesn't sound scary, does it? But tornadoes are pretty strong. They can have winds over 100 miles an hour. We don't see a lot of these in New Hampshire very often. But about a year and a half ago, we had a really strong tornado in the state. It went through 13 different towns and was on the ground for over an hour. It was the longest tornado on the ground that we've ever had in New England. This was just a year and a half ago. So we do get them here. It just doesn't happen all that often, and usually it happens in the warmest time of year, June, July, or August. This one happened in July. So again, most of the time you're not going to walk outside and see a tornado spinning around. This is not the type of area of the country that we see that. There are certain areas of the United States where you do see those a lot of the time, but not here most of the time. But if, anyone mentions tornado, or if I'm on TV telling you there's a tornado, that's when you want to be really careful and, find your parents, tell them I said tornado on TV, and, just kind of make everybody aware around you of what's going on at that point, because they're very unpredictable. They kind of move around, and they go from one town to another town pretty quickly. The tornado a year and a half ago was moving at 60 miles an hour. It was moving as fast as a car moves on the highway. That's how fast it was moving. So they're tricky that way. Not to present every scary thing that we know. What are these? Of course, they make them look really big here. Mm-hmm. A snowflake, yes. And snowflakes are nice, aren't they? Whenever they happen, you're not in school, right? Yep. You know what's great about snow, besides the fact that, whenever it snows, you're probably not in school, is the fact that you can have billions of these. And I mean billions of them falling from the sky at the exact same time. And if you look at these pictures really close, you'll notice that every snowflake that you see here looks different. And that's the really cool thing about snowflakes, is out of those billions of snowflakes that are falling in from the sky, every one of them look different. They don't all fall the same. They don't all look like the exact same shape. We all draw them the same, right? We always have that little star thing going on. At least that's how I draw them. But they all kind of have a different shape to them. And that's the way they work when they fall from the sky. We know that there are probably about 25 different shapes of snowflakes. Sounds crazy, I know. 25. That would seem, you would figure it would be like one or two. But there's a lot of different kinds, and it all depends on what type of cloud it's coming out of, what the temperature is as it falls through the sky, and what it eventually does when it lands on the ground. So when you watch them fall from the sky and they land on something, take a look at it and look really close at the snowflake, and then watch the next one that falls next to it, and you'll probably notice that they look just that little bit different. Do you guys know what makes rainbows? You need two things for rainbows. I had a kindergarten class last year. I asked them what made rainbows. They said, crayons. None of you were going to answer that, right? No. Okay. All right. Name one of the two things that you need for rainbows.
Rain and sun.
Rain and sun. Very good. Now, the reason we don't see rainbows every single day is because rainbows are one of those things that you need the rain and the sun to be in the sky at the exact same time. Not easy to do. But as I mentioned, sometimes thunderstorms and rain showers work on a town-by-town deal, where it could be over Nashua, but not over Merrimack, not over Pelham, not over Hudson, just over Nashua. And then in some other part of the sky, you could have the sun out. And when the sun's rays go through the raindrop, what you have to imagine is this being a nice big bright sun, and that raindrop, and see how it's a little bit clear through it, and you can almost see through the raindrop a little bit here? Well, that sunlight, when it goes through the raindrop, it creates these magical colors that you see on the other side. And you guys can actually try this in your own backyard. You can go outside with a garden hose in the middle of the summer on a sunny day and kind of put your finger over the hose a little bit to kind of make it spritz out a little bit as opposed to just come out. And when you do that, you can create that same effect. You'll notice near the ground a little bit of a rainbow develops. You can't really touch it. It's kind of a trick of the light. Now, do you know that in the middle of the winter, you can also get that same color happening? But in the winter, it's not rain that usually falls, right? What usually falls in the winter? Snow. So, sometimes sunlight can go through snowflakes. Now, when it goes through rain, it's called a rainbow. So when sunlight goes through snow and makes those colors, what's it called? What was that?
Snowbow.
A snowbow. That's right. Now you don't see them very often because snowflakes are not as clear as raindrops. They're a little whiter. They don't reflect as much light. But when you do see one out there in the middle of the winter and it's too cold for it to be raining, that's what you're actually seeing, is you're seeing something called a snowbow. So in my job, when I get to work in the morning, I usually have about 50 of these waiting for me every day. All right? I had that same kindergarten class, they called these spaghetti on a piece of paper. Yeah. This was not a kindergarten class that I argued with very much. These are the maps that I try to use. Now, what you're going to realize as you get older is that computers that you use at home and at school and, playing games with are always right. 2 plus 2 is always going to equal 4. The letter D is always going to start the word dog. Computers are always going to be correct. In my world, we've just been using computers for a very short amount of time. We haven't been able to really get these completely correct. So out of all the maps that I look at every day, only about half of them are right. I know that seems odd that computers can be wrong, but they're only as good as the information we as weather people put into them. So we use these, and they're pretty good. They're all right, but they're not always correct all the time, which is why the weatherman sometimes is not correct all the time. I know that seems strange as well. We're on TV, we're wearing these fancy clothes, we're pointing to numbers. You would think when we tell you that you're going to get 6 inches of snow tomorrow, that you would wake up tomorrow morning and there would be 6 inches of snow on the ground. Therein lies my job and the tough part of what I do. We're not always right. I wish we were. And I go in every day trying to predict the weather, wanting to be exactly right every single day. I really do, badly. But there are just some days that the weather just doesn't work out exactly how we think it was going to happen, or the computer maps, or everybody else. Is that weather is a little bit strange that way. It works town by town. Sometimes you guys here in Nashua can get 2 inches of snow. Manchester gets 6. Concord could get 10. Sometimes you guys get the really mean thunderstorm. Some days they just wind up with sunshine on that same day. Weather works town by town, and it's tough to get every single town every single day correct. Before we had computers, before we had electricity, no Game Boys, no Xboxes, none of that stuff. 500 years ago, let's say it's Christopher Columbus sailing the ocean blue in 1492, we can actually see that he had a pretty good idea as to what the weather was going to do, believe it or not. What do you think was the one thing he looked at out there to have a really good idea as to what the weather was going to do? They used to have situations where they would watch the cows. And if the cows were lying down, it meant sometimes it was going to rain. But the single most important thing that they used were these. What are these? That's right. They use the sky and the clouds to figure out exactly what the weather is going to do. Now, there are 50 different types of clouds. There's lots of them. All right? I'm going to show you just 3. Okay? Through these 3 types of clouds, you guys can be junior meteorologists. You'll be able to look at the sky, see what type of cloud is out there, and know what the weather is going to do just by looking at the type of cloud. Doesn't mean you don't check in on the morning show to see what I'm thinking that day, but you know what I mean. So here's the first one, okay? These are the highest clouds in the sky, all right? They're called cirrus clouds. These cirrus clouds are up higher than most birds and planes fly. They're up so high in the sky that they're actually not made of water droplets anymore. It's so cold up there that they're actually made of very tiny ice crystals, smaller than snowflakes. And what essentially these clouds do is because the wind is blowing so hard up there, and when you see these clouds from the ground, it doesn't look like they're moving all that fast, but they're moving about twice the speed of a car on the highway. They're moving at about 100 miles an hour. They're zipping right along up there. They don't usually give off precipitation. They're usually just up there, ice crystals. And these are the clouds that move ahead of a storm by about a day. Meaning, if you see these clouds out there, chances are that means that tomorrow or the next day, a storm's going to move in. That's what Christopher Columbus knew when he was sailing the ocean blue in 1492, trying to discover America. He saw these clouds out there. He's like, aha, I got to have my crew ready because chances are tomorrow the waves are going to get really rough. The wind's going to get pretty bad, and, you know, it might be raining or snowing really hard. So he knew that just by looking at the type of cloud. These are the clouds they usually bring in. I like to call these the yucky clouds. These are not the clouds you want to see when you wake up on a weekend and you want to go outside and play. These are called stratus clouds, okay? They're the lowest clouds in the sky. They're only in the first half mile of the sky, is all. They give us most of the precipitation that we see. Rain, snow, sleet, freezing rain, fog, drizzle, mist, all from stratus clouds. If you wake up in the morning to head to school and these clouds are out there, chances are by the time you're heading home from school, they're still out there. They don't move very fast. For some reason, they move out most of the time while we're sleeping. Well, while you guys are sleeping, I'm awake. But for the most part, these usually give us most of the precipitation we see. Doesn't mean it's raining all the time when they're out there. As a matter of fact, they're starting to drift in now, but it's probably not going to rain much today. But it does mean that there's a chance that there could be some rain or some snow. That's what that indicates. All right, here's the final one. These are going to look very familiar to you. These are called cumulus clouds, okay? Blue sky in the background usually means a nice day, most of the time. They have these big puffy cotton balls in the sky, and if you watch them up there, they're always changing shape. They change shape right in front of you to the point that if you watch it, you look away for about 20 seconds, then look back at it, it's going to look completely different. They move around a lot. They bubble up, they shrink, they expand. They can look like animals, they can look like your teacher's faces, that sort of thing, you know. Yeah. Well, these clouds most of the time mean nice weather, especially on a day like today. If you were to go outside and you were to see these out there, like, oh, really nice day. The exception to that is when it's a really hot, sticky day in the middle of the summer. When it's a really hot, sticky day in the middle of the summer, the heat near the ground, where it's really icky, sticky, rises and creates more clouds. And these clouds not only build outward, they build upward. And the taller they build upward, the more moisture they can hold, the more rain they can hold, and they eventually create what's known as not cumulus clouds, but what we call cumulonimbus clouds, which are what you guys know as thunderstorms. So on a really humid day in the middle of the summer, if you see these clouds out there during the day, it probably means there's going to be some thunderstorms later in the day. But on a day like today, is it humid out there? No.
No.
So if you see them out there on a day like today, the weather is going to be just fine. And that's how they used to be able to predict the weather. Now, besides the computer maps that I use, there's two other things that we're able to use to figure out what the weather's going to do. Oh, even better. The old-fashioned eraser. Got to be careful with my cold. I could use that. So there's two other inventions. I know it seems odd, but there was a time, only about 50 years ago, that we didn't get into space yet. We weren't sending space shuttles into space. And just as we started to do that, orbiting Earth kind of like the moon does, we would send up these weather instruments. And these weather instruments, as the Earth spun, would spin with it and would take pictures of the exact same spot over the Earth every 20 minutes. So there was always a, what we call satellite, spinning around right over New Hampshire. And every 20 minutes, it would take a picture right over New Hampshire. When it took that picture, it sent the picture down to Earth and gave us the image that we could use on television. The best way you see that on TV when I do my broadcast is you'll usually see me standing there and there'll be all these clouds zipping around behind me. That's what that is they are pictures taken every 20 minutes and all put together. Now, the reason this was important was, you have to imagine, before we had these, and there was a big hurricane out in the middle of the ocean, there was no way to know there was a big hurricane out in the middle of the ocean, unless a boat ran into it and radioed back, "We're in trouble out here." But what these satellites allowed us to do is watch every storm that developed, whether it was over the ocean or over land, which way it was moving, how fast it was moving, how strong it was. And it gave us a way to look down at Earth to have a really good idea as to what was going on at all times. Have any of you ever driven by our station in Manchester? Okay. Right next to our station, if you go up and look up at the top of the roof, there's a big satellite dish up there. It's a big piece of metal, a little pointy thing sticking out of it. And that pointy thing is what we call radar, or what we call on TV storm tracking. And what it does is it sends a beam slowly up through the sky in all directions. By the time it gets here to Nashua, it's about a half mile up in the sky. You know, it looks for anything made of water. It will look for a cloud giving off rain or snow. Let's say it finds a cloud that gives off rain. It will send the beam back to the satellite dish and make a map you can see on TV, where then on television I can show you where it's raining or where it's snowing, how heavy it is, and where it's moving. It does it every 5 minutes. What you see on television when I'm showing you that are these big green, orange, and yellow blobs on TV. That's what we're showing you, is where it is exactly raining or snowing and how heavy it is. It can also look inside the cloud and see where there are pellets of ice developing, maybe turning into hail, which can fall out of a thunderstorm. It can also look inside a thunderstorm and see what the winds are doing inside a thunderstorm, if the winds are moving really close together or if they're moving apart in a very small amount of space, almost the size of this classroom, from 20 miles away. It's pretty powerful stuff. And what that indicates is that there's a spin going on up in the thunderstorm, meaning there may be a tornado forming. So all of that can be done every 5 minutes by a radar dish that sends that beam slowly up through the sky. We didn't have this 25 years ago. So when the tornado happened a year and a half ago, we were able to follow that storm town by town. Where 20 years ago, we wouldn't have been able to do that. So there's a lot of computer stuff that we use now that we didn't have 50 years ago that allows us to be able to make predictions or tell you what's going on now that we would have never been able to otherwise. I'm going to open this up to any questions you guys have. And then I'll describe how I do what I do on television. Yes?
How long have you been working?
I have been, oh, this is the scary part, because now I'm dating myself. I have been on the air now for 15 years doing television weather. I'm getting old.
When is a tomato coming?
Well, I mean, the best time for us to have a chance of a tornado usually is in the hottest time of year when the most thunderstorms are out there. So that usually is when you guys are out of school. Late June, July, and probably most of August. So most of the time when you guys are in school, it's cool enough that we don't see a lot of thunderstorms. The chances are much smaller that we'll have that, you know, during the hottest time of year, when there's more humidity out there, when the thunderstorms are their meanest. That is probably our best chance to see a tornado if we do. But again, we don't see them very often. In the state of New Hampshire, we probably see about one a year. And most of them aren't strong enough to be on the ground for over an hour.
What's your favorite weather?
What is my favorite type of weather? Believe it or not, right here.
Sun?
You know why? I know it doesn't sound fascinating. You'd probably want me to say tornadoes or lots of snow, but this means that most of my viewers are very happy on television. And it's all about keeping the viewers happy. There has not been anyone happier than me the last 3 or 4 days. It has been very nice out. I think people needed this. It had been very cold for a while. We had a lot of snow. A lot of the snow is melting now. Now, whether we still see more snow, I'm not ready to say that winter's over yet. Not going to do that. As a matter of fact, I'm going to find some wood to knock on here. All right here. But it's one of those situations that I enjoy the sun just as much as everybody else. I think a lot of people think weather people love big storms. I get nervous around big storms. I'm one of those people that's actually afraid of weather. I know that seems odd, But it's one of those situations that we enjoy the nice weather along with everybody else. Yep.
Do you like being a weatherman?
Do I like being a weatherman? Absolutely I do. I really enjoy doing what I do. It's hard to imagine me doing something else. I would probably be doing something else with weather if I wasn't doing TV weather. I'd be on the radio, or I'd be working out at the Manchester-Boston Regional Airport doing weather observations, doing a study on air pollution, ocean currents. There's a lot going on that we don't understand. And as I mentioned earlier, we don't understand everything about weather. We don't understand why some tornadoes are as thin as this marker and others are a mile wide, why some of them are two that combine into one tornado, or you can have one large tornado that splits into two. We don't understand completely how hurricanes move the way they do, which is why we have scientists out there all the time trying to figure these things out. If you were to ask me today what creates a tornado, I could give you an answer and draw you a really fancy diagram, but chances are by the time you guys are my age, the diagram could be completely different. We always have people out there studying these things, and there are people that go out and chase tornadoes. And the reason they do that is not because, they're really crazy, even though I wouldn't do it. It's because we need to learn more about them all the time. And so they'll take these big trucks and they'll go out during thunderstorm situations and they'll put a big radar up on the back of the truck. And when they get near one of those thunderstorms that look mean enough that it may create a tornado, they send their beam up into the cloud to try to figure out what's going on inside that thunderstorm. And then some of the time, a tornado comes out. And when the tornado comes out, they have a better understanding of what's really going on inside that thunderstorm. Why is the sky blue? Oh boy. One of the most difficult questions I ever get. Why is the sky blue? Usually the kindergarten answer for this is it's a reflection of the ocean, but that would be just mean to do that to you, and especially since I'm on television, that's not a good idea. Okay. The sun and its rays, here it is, the sun. When it comes toward Earth, okay, you have to imagine the Earth is round. And when the Earth is round, the sunlight doesn't always come in directly. It doesn't hit us direct on. Sometimes it skims off the top of the Earth and continues on out through the rest of space. Sometimes it comes in at a very strange angle, and sometimes it comes down directly at us. The sun's rays come in all, and it's not just one straight line. It's like, it's like a flashlight. If you were to have a dark room and a big globe, you shine a flashlight at the globe, some light is going to hit some parts of the Earth. On the back side of the Earth, it's going to be dark, so it's nighttime. And it comes at different angles and different strengths during different times of year. That being said, when it comes in on that angle, there are certain particles up in the sky, in the oxygen that's up there, that deflects certain parts of that sunlight. Some of it reflects right back out into space. Some of it comes right toward the ground. One of the particles, for some reason, that is left over is about this exact color blue. Okay? So that is the color that we see. Now you'll notice on a really blue sky kind of day, you'll notice if you look at the big sky and there's no clouds, if you look straight up through the sky, like right above your head, the sky is exactly that color. It is a really beautiful blue color. But if you look closer to the edge of the sky, the horizon, out near the mountains, or as far as you can see closer to the ground, you'll notice that it isn't that exact same color. It's more of a very light blue, almost a white color. And that's because the sunlight is coming in at a different angle at certain parts of the sky. And so the only color that is left over as it comes in that the particles don't take away is the blue. And so the blue is the part that we see. Is that better than a reflection off the ocean? I'd much rather the reflection off the ocean. It's much easier to answer. Yes?
What kind of instruments do you use?
Kind of weather instruments do we use? Lots of different kinds of weather instruments. Do you guys know what measures temperature? Thermometer, very good. There are other instruments that measure the pressure in the sky, called barometers. If you ever go to the airport and you're sitting on the runway waiting to take off and you look out in the distance, sometimes you'll notice these big white weather instruments out there, and they have a little suction cup on the top that's spinning around really fast, that little whirligig. That's called a wind gauge, otherwise known as, nice big long word, anemometer. I never say that word on TV, I always mess it up. And believe it or not, 200 years ago, they used to measure humidity. Today, we have what's called a hygrometer or a psychrometer. But 200 years ago, they knew what you girls know now. What happens to your hair on a really humid day? Gets sweaty and gets frizzy, right? Mine gets frizzy anyway, I kind of help it along. But you know what I mean. On a really humid day, your hair just doesn't want to stay out straight. It just goes boing. Well, they knew this 200 years ago. So what they did was they actually took hair off of a horse. The horse was fine. They didn't hurt the horse. And they laid it out on a weather instrument with a couple of prongs holding each side of the piece of hair as tight as they could. And when they did that, on a dry day, a non-humid day, the hair, like yours, would stay out straight. But on a really humid day, that hair would want to frizz up. And when the hair would want to frizz up, it'd want to pull toward the middle so it could frizz. The amount of pull toward the middle indicated how much humidity was in the air. And it was called a horsehair hygrometer. And that's how they used to measure humidity, was through horsehair. Now we don't have to use horsehair anymore. We've got much more, we have, more complicated weather instruments that can do that kind of stuff without needing horsehair to do it. So the horses are much happier. But that is a good portion of some of the weather instruments that we use. There's one last one. It's called a weather balloon. Every morning at 7 a.m., every evening at 7 p.m., the National Weather Service, which is the group that guides all the forecasts, sends up a weather balloon in the exact same spot. And all these balloons at 7 a.m. and 7 p.m. rise through the atmosphere. And as they go up through the atmosphere, they have a little weather instrument that measures all those things we talked about: temperature, pressure, humidity, wind. And as they go up through the sky, they eventually, about 2 miles up through the sky, they pop and the weather instrument falls to the ground again. But as they go up through the sky, they measure what the atmosphere is doing. And about 3 hours later, that is when we get these back. That's what we're waiting on, are the weather balloons. So these balloons, when they're sent up, gather all this information. They get sent to one big computer, and all the information gets churned out for us. And so that's how we get the computer maps that we get. So that's a combination of all the different weather instruments we use in a weather balloon to get us a really good idea as to what the weather's going to do. Mm-hmm. Why do we see blue skies? These are good questions. They're smart. Very, very smart. Well, I mean, the blue sky is essentially what is left when there are no clouds, when there is no precipitation, and it's just when the sun is out all by itself. Now you'll notice as the sun goes down later in the day, the sky doesn't look that blue color anymore. What kind of color does it kind of turn near sunset or near sunrise in the morning? It's got kind of this yellow or orange or pink color to it. And that's because as the sunlight goes down, it's hitting the sky at different angles. Instead of hitting it from straight up and down, it's hitting it from this side, or it's setting, and so we're getting almost kind of an up kind of angle. And so the blue sky essentially means that there are no clouds, no rain at the time, and usually the sun's out at that point. But, some of the time it's not necessarily blue. Sometimes it can be pink, it can be like a reddish color, even a little bit more of an orange. And that can sometimes happen, especially right near when the sun is rising or the sun is setting. Yep.
How many years were you in TV?
How many years on television? About 15 now. And when I went to school to study weather, it's about 4 or 5 years to study weather. Learning about thunderstorms, about clouds, how to predict snow, how to be on TV, how not to be nervous on TV, which can take 4 or 5 years to learn as well. But all of that happens through learning in school. It's a lot of math, it's a lot of science, but it's a really fun job. I mean, all that learning, eventually you're rewarded by doing a job that you really love to do. And that's probably the best advice I can give you guys today, is someday after school, you're going to have to work every day. Your teachers will tell you they really enjoy what they do. They don't do it for the money, do they? No, not from anything I've heard. But it is a lot of fun if you find a job that you really love doing. So what you do through these next 10 years of school, besides a lot of homework, is you'll find what that thing is that you really love. Whether it's learning more about frogs, or doing math equations, or reading books, or writing your own book. You'll find what you really like to do. And hopefully that is the job you can have when you get older. Because doing it 5 days a week, you want to have fun. And I'm lucky enough to have a job where I have fun doing what I do every day. It is a lot of fun. All right, let me give you guys my most embarrassing moment on television. What you have to imagine is when we're on TV, the minute I mention something to you, you see it at home. There's no way to go back and change it. There's no way to go back and start over. We're not on tape. We are live, just like I'm talking to you now. So when you're on television for 15 years, live television, sometimes bad things happen. And this was one of those days where a bad thing happened. It was my first job about 13 years ago. I was out in Iowa, and at that job, we had 2 feet of snow. We had the wind blowing about 40 miles an hour outside. I got to work on Wednesday, and it was now Friday morning. I couldn't get home because there were 2 feet of snow. And I'm up there doing the weather broadcast in our studio. And when I'm up there, the lights go completely dark because the wind's blowing so hard, the power goes out. So I kind of feel my way back to the anchor desk, and I sit down next to my anchor, Amy, and we sit there and we talk for a little bit. And after about 3 minutes of talking in the dark, we hear the generator outside kick in. Boom, lights go back on. We start the show back up again. This happens 4 times during our morning show. It kind of got annoying after a while, but every so often the wind would pick up, the lights would go out. We'd have to wait a few minutes, the lights would kick back on again because the generator would kick back on. After the show's over, thinking we'd done a pretty good job in the circumstance, we go up to the newsroom. And in the newsroom, 13 years ago, we didn't have email and all this other stuff. We just had an answering machine. And we noticed there were 50 messages on our answering machine, which we thought was strange because all the schools had already been closed for a couple of days. All the businesses had been closed. So we listened to the first message, and the first message is, Amy, it's great to hear you had a nice weekend last weekend. And Amy and I look at each other, we're like, that doesn't make any sense. The second one was, Kevin, why didn't you really tell us what you thought was going to happen with the storm? And that one didn't make any sense either. And this went on for about 40 different messages. And at that point, we just decided, okay, people are having fun with us. They've been stuck inside for 2 days. We go back downstairs. We've got to continue the show. After the next segment, we come back upstairs, and our boss is in his office laughing hysterically. And he calls us in. He says, Amy, Kevin, come in, sit down. I have to explain something to you. We live in Iowa. Tornadoes happen here all the time. And a tornado could very easily hit the station. And if it does, we have to have a way to be able to communicate to the viewers, even if the emergency is in our own building. So even though the generator hasn't kicked in outside and the lights are dark, there are certain things that are left turned on. One of which was my weather computer. I didn't realize at the time, probably because I had been so tired and stuck at work for 2 days, I didn't have to go up and reboot my weather computer every time the power went out. The other thing that was left turned on in that situation were our microphones. So imagine you're watching at home and the power stayed on where you live, so your TV's working just fine. But the lights go out in our studio, so you can't see us anymore. It just looks like a black screen. Our microphones are working the entire time. So Amy and I in the dark are talking about her weekend. We're talking about how I should have predicted another foot of snow. what we're going to tell people when we come back on TV to let them know we're okay. Amy and I had no idea, but people could hear everything we were saying. The joke was on us. Now, in big cities like New York, you could be fired for something like that. You could be let off your job, even though you had no idea what was going on. Our boss thought it was so funny that he decided to sell copies of those shows to the viewers for $10 a piece. And they sold thousands of these videos because everyone was at home, everyone was watching. We were the only station in North Iowa. So we got to relive that joke many, 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 many times. Now, do you think Amy and I saw any of the money they made on those videotapes? No, of course not. You guys know more about TV than you think. Now, even though we've been broadcasting here today, do you guys also want to be on television? Yeah. All right. I'm going to leave this up to the teacher. I will give you the choice between today at 5:15 or tomorrow at 5:15 in the afternoon. Is today enough time for them to be able to get home, tell their parents that they're going to be on today? I just don't want 3/4 of them to miss it.
Let's do tomorrow.
Tomorrow at 5:15?
Yep.
Okay. So here's what I do. I bring a very small video camera with me as well. See? Cameras follow me wherever I go. There's nothing I can do. This camera allows me to take video and bring it back to the station and show it on television. So, what I will do is, I will make some video now. I'll zoom around the room, and with this, bring it back to the station today, and tomorrow at 5:15 in the afternoon, you'll see me doing my weather broadcast tomorrow. And right after I finish my weather broadcast, there's usually a nice big, what we call a 5-day forecast. It's like telling us what the weekend's going to be. At that point, on Channel 9, after that, you'll see the video that I'm about to shoot right now. Okay? Now, there's no audio to this. There's no microphone, so there's no reason to yell, "Hi, Mom," on TV or anything. Your mouth will just be open. But what it will do is I'll pan around. You guys can just wave to the camera. I'll go slow enough that you'll be able to find yourself. And you can wave. And, oh, they're already waving. All right. Slip under the sun. Not often I don't get to try to avoid the sun. I'll come back through one time. You're so quiet. We got it. Nothing worse to tell kids they're going to be on TV and then have to yank it away.
Difficult to deal with many times.
Every once in a while. But thank you very much for having me here. They were a great audience.
We have something for you.
You were right. I was worried about squirm factor at minute 30.
No, they've done
Nothing.
great, huh?
Fantastic.
We have a book from the kindergartners, from the 3 classes, that they've done on their favorite types of weather.
Oh my
Yeah,
goodness.
it's beautiful. They did all the writing
Oh my
and
goodness.
illustrations themselves.
Oh, that is
Yeah.
fantastic.
Yeah.
We will put this up in the weather office.
Yeah.
I'll try to read 1 or 2 of them on TV tomorrow.
Oh, great.
All depends on how much time
Yeah,
and
how
how
much
much
time you
news
have.
time, yes.
Yeah.
They're always yelling in my ear, "You've got to stop. We're running out of time." They're always telling me that because we weather people, that's all we do is blah, blah, blah.
Yeah.
This is great. Thank you.
A lot of them like snow and sunny days. Yeah.
No one likes tornadoes, right? No. Okay, see, that's very good. That's good. Okay.
Jumping in the puddles.
Going into the pool. Yep. Hot weather. Sure. A lot of them like summer, it seems. Yes. Understood. But thank you for having me. They were fantastic.
Thank you for coming. What do you say, kindergartners?
And thank you. This is great. Thank you very much.
Nice job on the cover, Andy. Nice job on the cover.
Wow. That does look very, very nice.